Okay, so now, right, let's really go to a really powerful tool of our calculator, which is it actually helps us solve equations. So if you look at what I've kind of handwritten here, each one of these equations we've actually solved somewhere in our course. I think particularly during our first week. So for this one, it's a quadratic, so we use the quadratic formula, or we can complete the square. Here, the absolute value, we move the 10 over and create two equations and solve. Here we'd isolate the radical, square both sides, and solve what's left. So all of these can be done algebraically, and again, that's usually what I'll expect, right, on quizzes. So we're going to concentrate on that. But what's nice about the calculator is you can at least check your answers, right, using some of the tools that I'll have here, as well as analyze some functions as we'll see and get some important data. So again, everything we're going to be doing, remember the calculator estimates things. The algebra gives us exact answers. So, which one we want depends on things. Like I say, quiz, I'll usually want exact answers. I want to see you doing the algebra stuff you've learned. But to solve equations, there's actually two ideas. And you're going to see the first one, and I'll share the second one with you next. But what we're going to do is take advantage of the concept of x-intercepts. This is idea number one. And the reason we're going to do that is this guy right here, right? When I enter it in my calculator, that's going to be y equals 3x squared plus 5x plus 1. And if we let y equal to 0, we know that is helping us find x-intercepts. And lo and behold, somebody's already done that. So this is essentially, right, in algebra or math speak, it's asking us for the x-intercepts. When does y equal 0 for that function? Same thing down here, right? When does this function equal to 0, right? When are we at an x-intercept? And the same thing down here. So to do this with that theory behind it, we're actually going to enter, so let me grab my calculator here, y equals, first of all, let's go back to our zoom and get this back to its standard viewing rectangle. We're going to go to y equals, it's still putting that big function in there. Sorry, I should have cleared it. Y equals, let's clear that function out. And what I want to type in is 3x squared plus 5x plus 1. All right, so again, we're expecting a parabola. And there's the parabola. And we can kind of see, right, it is in fact crossing the x-axis twice. Once here and once there. And we're still kind of far back. So how about, let me go use the zoom feature, right? Let's go ahead and zoom in. To do that, right, what I'm going to do is put my cursor, it's already on the origin, but if you want to move it, how about we move it to the left a little bit? It's kind of put something right between, I don't know if you see the cursor moving there, but put it right in between there. Let me press enter, and it's actually going to zoom in on that, so we can kind of see those zeros, right, or those x-intercepts just a little bit better. So we can clearly see that we have two. So how do we find them? How do I pinpoint what that is and that is? Well, number one, because we're on a calculator, you're not going to get the exact answer. That's where the algebra is in. But here, what we're going to do is get an estimate. And what you do is you go to, right, the calculate feature, right, of your calculator. So right above trace is the key called calculate. So we need to open that up. So once I open that up, it's going to allow us to calculate a lot of things, values, minimums, maximums. But the one we're looking for, another way, as you'll see in this class, another name for x-intercepts is zeros. So that's the language the calculator used. So to find an x-intercept, I need to hit 0. Now what happens are a couple of things. You'll notice that the cursor is now on the graph itself, right, and it's asking me for a left bound. So let's go find that 0 over here. What I need to do is move my cursor, and you just do that by, notice how it's moving left to right along with that. But I move my cursor so that the cursor, right, represents an x value that's to the left of the one that I want. There's actually an infinite number of them, so you can choose whatever one you want. How about I choose that? Once you have it, press enter, right? And it puts a little tick mark. Now it's asking for a right bound. So I'm going to move my cursor, and I want to be somewhere on the graph, right, where the x-coordinate is to the right of the one that I'm interested in. So press enter. And then it asks for a guess. So I just, move your cursor into as close as you can to, that looks like as close as I can, and press enter. The calculator is going to work, and lo and behold, boom, it pops out the answer. So it tells us that that x coordinate is roughly negative 1.4343. How about I go 4 decimal accuracy? All right, so that, right, and then of course y is equal to 0 being the x-intercept. That is one of our solutions. Of course, we see that we have another solution over there, right? So what's that other one? Well, again, we're going to basically go to calculate. We're going to look for a 0, right? And then we're going to have to move my cursor, so kind of we're tracing here, to some point that is to the left of the point of interest. So that x coordinate, if I press enter, right, notice that giving me an x value that's to the left of my point of interest. Now it's asking for a right bound. So I'll move somewhere to the right. I'm way to the right. And then it's asking for a guess. And press enter. And then what that returns is a value of negative 0.2324 if I go to 4 decimals. And then y is equal to 0. So there, right? And these correspond, hopefully, if we use the quadratic formula, right, we're going to get x equals like negative 5 plus or minus 5 squared, yada, yada, yada. So the plus route and the minus route should coincide with those decimal answers as well, and that's a way that you can check that your algebra matches your calculator. Right? So we're already 6 minutes into this, and I have so much more. How about I break off? There's your introduction and one idea, right? The x-intercept idea and how to solve this. So let me go ahead and do the next two in a separate video, so that way it's not so long and we can spend some time with them. But see you in the next video.